So now we've got Jim throwing a stone down the well. Oh, boys will be boys. So I'm going to start by giving the distance or the depth of the well a letter. Let's call it D. Then we can see how long the sound takes to get back from the pebble hitting the water by using speed equals distance over time. And then when we do that, we get the time that the sound takes to get back from the bottom of the well is that expression there. So now I can look at the journey of the pebble down the well, and if that's going with a constant acceleration of 9.8, then the distance it travels is going to be d. Initial velocity is 0. We're not interested in the final velocity. But what about the time? Well, Jim reckons it took 4 seconds for him to hear the splash. So if the sound took this length of time to return, then the time it took the pebble to get down to the bottom of the well must be 4 minus that. So those are the values for the Suvat equation. Now I'm going to put those into the equation S equals ut plus half at squared. So that's what the equation now looks like. This is 0. A half of 9.8 is 4.9, and then I can multiply these brackets out. So that gives me that, slightly better looking, although some dodgy looking numbers in there. Then I take the d over to the other side and multiply the 4.9 to give me this quadratic. So it's then just a matter of popping that into my calculator and getting the answer 70 meters. Now I've only expressed that to 2 significant figures. You might be forgiven for saying 70.5, but the reason I've chosen 2 significant figures is that the calculation is based on our acceleration due to gravity, which has only got 2 significant figures, and our time, which has only got 1 significant figure. So anything more accurate than 70 is really questionable. So we've found out how deep the well is. What modelling assumptions have we made? Well, we've made a number. We've made an assumption that we can use constant acceleration. We've made an assumption about the initial velocity, and we've made an assumption about the acceleration. So writing those and 1 or 2 others down as well. So we're assuming that the pebble is a particle, which means we don't have to include air resistance or rotational effects. We're assuming that the 4 seconds is accurate and that acceleration due to gravity is 9.8. It might be exactly that, or it might be slightly different. We're also assuming that Jim does actually drop it from rest from the top of the well, and that the pebble doesn't hit any part of the well on its way down. So quite a lot of assumptions going behind that, and that's another reason why this 70 meters is probably only the level of detail or the level of accuracy which is justifiable. Okay, so that's my answer to the question.